Somewhere deep in the universe, there is a faint yellow dot, tiny, easy to miss, just one speck among thousands in a single image from the James Webb Space Telescope. Nobody expected it to matter. Nobody expected it to be the thing that cracked modern physics wide open. But it was. That dot turned out to be the most distant galaxy ever seen, existing when the universe was only 290 million years old, and it didn't look like a baby. It looked like it had already lived for billions of years, structured, massive, complete. A full-grown cosmic city in an era when only scattered building blocks were supposed to exist. And when the numbers came back from spectroscopy, the room went quiet. The distance was real, the age was real, and nothing in our models could explain it. Here's where it gets strange, because that galaxy wasn't alone. Webb kept looking, and the deeper it stared into those dark corners of the cosmos, the worse the news got. Not one impossible galaxy, not two, dozens, then hundreds. A recent study catalogued 87 potential galaxies forming between just 200 and 400 million years after the Big Bang, a number so far outside what our models predict that one of the scientists involved admitted publicly. Even if only a few of these are real, we have to rethink everything. Everything, not a small correction, not a footnote update. Everything. The foundation of modern cosmology is a model called Lambda CDM. It describes how the universe grew, slowly, patiently, from a hot, dense beginning into the vast, structured cosmos we see today. It predicts how galaxies form, when they appear, how massive they can be at any given point in time. And Webb just lit that model on fire, but it gets worse, much worse. In every galaxy we have ever studied, there is a cosmic rule so stable, it's almost boring. Roughly 10% of a galaxy's gas ever becomes stars. The rest gets blown out by radiation, recycled, scattered. Star formation is slow, inefficient, governed by cycles of collapse and cooling. This rule holds everywhere. It always has. Until Webb found 3 objects in the early universe where 100% of the gas had converted into stars. Every atom, every molecule, all of it burned into stellar fire. That is not a galaxy behaving strangely. That is a galaxy breaking the laws of physics. We don't even have a name for what these objects are. They're too compact to be normal galaxies. Too luminous to fit any known prototype. They don't match quasars. They don't match protogalactic clusters. They don't match anything in the catalogue of cosmic structures we've built over a century of astronomy. Some scientists are now saying it quietly, carefully. These may represent an entirely new category of cosmic object, one we have never encountered before, one that predates every model we have ever developed. And if that's true, what else are we missing? Here is something even harder to digest. Much of what Webb is seeing shouldn't be visible at all. The observable universe has a boundary, not a wall, but a horizon defined by how far light can travel in the age of the universe. Beyond that horizon, galaxies are receding faster than light, and according to relativity, their light should never reach us. But Webb sees them, galaxies that should be permanently out of reach, galaxies whose photons should have been outrun by the expansion of space itself. And yet, there they are. The standard explanation says the horizon itself shifts over time, pulling distant objects gradually into view. But the objects Webb is finding push that explanation past its breaking point. We are observing things that our equations say we should never be able to observe. And that either means relativity is incomplete, or space is shaped in a way we haven't imagined yet, or the early universe played by rules we haven't discovered. The answer nobody wants to say out loud is starting to seem unavoidable. What if the Big Bang wasn't the beginning? Some of the most respected physicists alive, including Nobel laureates, are now openly entertaining the idea that the Big Bang was not a birth, but a transition, a phase change, a moment when a pre-existing universe shifted into a new state, not the origin of everything, but a dramatic transformation of something that was already there. And if that's true, then the ancient, fully formed objects Webb is finding aren't early galaxies at all. They are fossils, remnants of a cosmic era that existed before our universe as we know it began. Think about what that means. It means the Big Bang didn't happen at one point. If the universe was already infinite before the transition, then the Big Bang happened everywhere simultaneously, across an endless expanse of space that already existed. There was no single point of origin, no singularity, no moment when time began. The universe may have always existed in some form, stretching back not just billions, but perhaps infinitely into the past. And Webb, staring into its golden infrared eye, toward the edge of what light can show us, may have just captured the first real evidence of that eternal cosmos. What we are left with is not a puzzle with missing pieces. It is a puzzle where the frame itself has dissolved. The timeline is wrong. The formation physics are wrong. The expansion assumptions are wrong. The very idea that there was a clean, singular beginning to everything, wrong. Webb didn't just find strange galaxies. It found a universe that refuses to fit the story we've been telling about it for 100 years. The data is not changing. The universe is not going to behave itself to match our models. So something else has to change. And that something is everything we thought we knew. Physics isn't just trembling. It's being rebuilt from the ground up. And the telescope pointing, the way isn't finished yet. It's just getting started.